Solving complex equations. Your essential question today is, how do I solve equations that require multiple steps, meaning you have to do more than just a couple of operations to get the variable by itself? When you're solving any equation, whether it's simple or complex, there's two things that I want you to remember always. First of all, do the math that the problem tells you to do. Algebra is usually pretty straightforward in the beginning when you're doing algebraic manipulation, and if you'll simply do what it's saying, then you can simplify a problem down to allow you to think through the rest of it and find an answer. After you've done all the math that the problem tells you to do, secondly, isolate the variable. Remember, isolate means to get it by itself. We want the variable all alone on one side of the equal sign, and the number, the answer, or the solution to be on the other side. Let's do an example to show you what I mean. You'll notice that example 1's a little more complex than the equations we solved yesterday. But we're going to do what I just explained, where we first of all look at the problem and do what it tells me to do. I'm going to look at the left side of the equal sign first. That's everything over here. It says to do negative 4x minus 6x. I can do that because they're like terms. So when I combine those, I end up with a negative 10x. On the right side of the equal sign, I read, and I see that there's really not any math to do. It just says negative 20. So I'm simply going to bring it down. Don't forget that equal sign. It's kind of hard to see with the purple on the red, but always bring your equal sign along for the ride. Now I'm going to look at the right hand, at both sides again, and I see on the left a negative 10x, and on the right a negative 20. There's nothing I can do to either side there. I'm not going to add anything to it or subtract anything from it or multiply it times anything. So now I'm at step 2, where I simply want to isolate the variable. I want to get that x all by itself. To get the x by itself, remember to do the opposite. The opposite of negative 10 times x is to divide by negative 10. I do it on both sides to make sure I keep my equation balanced. Remember that the negative 10s will divide. So negative 10 divided by negative 10 is 1, which leaves me with x. I bring down the equal sign in the middle, and then do the math on the right. Negative 20 divided by negative 10 is a positive 2. My x is all by itself on the left-hand side of the equal sign. There's no number or negative or anything else with it, so I know that I'm done. Once you get done with your solving equations, always make sure that you check your answer somehow. Today we're going to check them by hand. So right over here on the right-hand side, we're going to show that we're going to check our answer by simply plugging this solution back into the original problem. The solution tells me that x is the number 2. So I should go back to the beginning, at the very original problem, and I should take out all the x's and replace them with 2's, because now I know what the x represents. So right here to check my answer, instead of writing negative 4 times x, I'll write negative 4 times 2, because x is equal to 2. The same thing here. And then I simply bring the equals and the negative 20 along for the ride. Now I'm going to do the math. When I multiply the 4 and the 2, I get the negative 8. Then the negative 12 when I multiply the 6 and the 2. And the negative 20 still along for the ride. I'm going to continue doing the math. Negative 8 minus 12 is a negative 20. Bring down everything else. And now I notice there's nothing left to do. There's no math on the left, and there's no math on the right. It simply says negative 20 equals negative 20. So I ask myself, is that a true statement? Absolutely. Negative 20 is exactly equal to a negative 20. So I can tell myself that this is a true statement. That means that this answer that I got right here is correct. It means I did all the work right, and I can go on to the next problem. If I'd done all the check work and it had said false, because negative 20 equals, say, negative 17, that would not be a true statement. I would have to write false, and that would tell my brain to go back to the original problem and figure out what I did wrong, because I didn't have the correct answer. Let's do another example. This time when I look at this problem, I notice that I have variables on two sides. Here's an m on the left, there's the equal sign, and now there's an m also on the right. But that's no big deal. I'm not going to let it throw me because I know how to solve complex equations. First, I'm going to do the math that it told me to do. So I look at the left-hand side of my equal sign, and I see 8 times m minus 2. That tells me that I can't do any math because 8m and negative 2 are not like terms. So I'm going to jump over and look at the right. There's no math to do on the right-hand side either, so now it's just a matter of isolating the variable. Well, if there's two variables, it's kind of difficult to isolate, so how about I put them together on the same side of the equal sign, then I'll only have one to deal with. So I always want to move my variables in a way that's going to leave me with a positive answer. So in this case, I'm going to take this negative 7m and do the opposite on both sides because I want to make sure that it's balanced. I could have moved the 8m over to the other side instead if I'd wanted to, but that would have left me with a negative answer when I got done, which is perfectly fine, but I don't like negatives, so I'm trying to make it easier on myself. Now when I do the math, 8m minus 7m is 1m. Bring down the negative 2 and the equals, and now let's do the math on the right. There's nothing to do with the negative 9, so I bring it down, because 7m and negative 7m will subtract to give me 0. I'm not going to write anything down here. Remember, we could have written plus 0, but that's extra work, and we're not going to do that. So now, reevaluate. Am I done? Is the m by itself yet? Well, it certainly isn't, so I'm going to have to continue isolating it. I see that it has a negative 2 stuck on the end, so I'm going to remove that by adding 2 to both sides. Now bring down everything by doing the math. 1m is going to simply come along. I'm just going to write m because, again, remember the 1 is not necessary. I know there's 1m there by simply writing m. Negative 2 plus 2 gives me 0. The equals comes along for the ride, and negative 9 plus 2 is a negative 7. The m is isolated, so I know that I'm done. Now make sure you check your answer. When I do the math on the left, I end up with a negative 58, and the math on the right gives me a negative 58. This is a true statement. Negative 58 does equal a negative 58. That means that my answer was correct, so I can box it and go on. This time in problem number 3, I noticed that I have the distributive property that I'm going to need to take care of first. That's the math that the problem is telling me to do. So to begin with, I'm just going to bring the 12 down because there's no math to do on the left-hand side. Now let's do the math on the right-hand side. Remember, the distributive property says to multiply this guy times everybody on the inside. I'll start with negative 4 times negative 6x, and then multiply the negative 4 by the next term, which would give me a positive 12. Now that I've done the math on the right side, I'm going to reevaluate this next step. Is there any math to do on the left? No, there's not. And I also see there's no math to do on the right. 24x and positive 12 are not like terms. So now I can move on with isolating the variable. I notice the variable is over here on the right-hand side. So I'm going to be moving everything to the left to get the variable all by itself. The opposite of 12 is negative 12. That leaves me with 0 when I do the math, because 12 minus 12 is 0. Bring down the equal sign. This also gives me 0 on this side. But I don't have to write it this time, because I have 24x as my placeholder, and 24x plus 0 doesn't change anything, so I'm not going to bother writing it. Notice that I did have to write it over here on the left because there's no other number to hold that place. I notice that x is still not quite by itself, so let's do one more step, hopefully, and then maybe it'll be all alone. 24 times x, well, the opposite would be dividing by 24. And when I do the math, 0 divided by anything is simply 0. Bring that equal sign down. 24 divided by itself leaves me with 1. So the x is all that remains. Make sure you check your answer. So when you do all of the check work, you'll notice that 12 does equal 12. That means that the answer x equals 0 is the solution to problem number 3. The last example is just a little longer, but it's the exact same process that we've been using thus far. First, I look at the left-hand side of my equal sign, and I notice that there is a little bit of math to be done. So I simply read from left to right and do what it says. It says to multiply 2 times everything inside here. So that's what I'm going to do. 2 times -3 is a -6. Don't forget this -8 on the outside. I'm not supposed to multiply the 2 times that guy because he's not inside the parentheses. He simply is along for the ride, so bring it down. Don't forget your equal sign. And now let's do the math on the right. Fortunately, there's nothing to do because they're not like terms. Now I'm going to continue doing the math. Back to the left, an x term minus 2 constants. Those are not like terms, so the 8x is simply going to come down. However, -6 and -8 are like terms, so I'm going to combine those because I can. That gives me a -14. Everything else comes down. Now this is a good spot because there's no more math to do. 8x and 14 are not like terms, and neither are the terms on the right. So now I can go through the process of isolating the variable. Notice there are variables on both sides, so let's move the positive variable over because when it becomes negative, 8x minus 2x will leave me with a positive 6x. Again, if you had chosen to move the 8 to the other side instead, that would have been perfectly okay. The -14 is along for the ride, the equals, and the 4 as well, because the 2x minus 2x gives me 0. It goes away. The x is still not alone, so I can get rid of the 14 by adding 14 to each side, because -14 and positive 14 are opposites. 6x equals 18. Don't worry about the gap right there. I'm just trying to keep everything lined up. This says that 6x equals 18, which tells me my variable's not quite alone just yet. The opposite of 6 times x is to divide by 6 on both sides. That leaves me with x equals 3, because 18 divided by 6 is 3. One more time, plug your solution back into the original problem to make sure the solution you got is correct. When you do the math on either side, you'll find that 10 equals 10, which is true. So x equals 3 is a correct solution. Today's your lucky day. Since we're still so very new at learning Cornell Notes, I'm going to model the questions in the summary portion for you one more time. Go back up to the top of your notes and take a moment to copy down the questions that I've written for you. And since you probably have run out of room on this page, turn it over to the back to complete your summary. Make sure you have these with you when you get to class tomorrow so we can use them.